Hello, for those who are new and to flat earthers who refuse to believe in reality, I thought I would make this quick video. I set up two cameras almost 2 years ago. One is pointing at the North Pole or slightly off from the North Pole. You can see that I'm at an altitude of 42.2 degrees with an azimuth of 348.9. And the other one is facing south, whose zenith angle matches my latitude more or less. And I made a video about the placement and why it had to be in that position. But in this video, I want to talk about the North Pole and the Earth's sidereal day that is not the same as 24 hours. As I was approaching the 1 year anniversary of the cameras being set up and the computer recording the images every minute, 24 hours a day, 7 days a week, I wanted to celebrate the 1 year anniversary by doing something with the data. I was trying to figure out what to do, and I ended up writing this app that ultimately took a life of its own. So at the end of it, based on the time from the start of the project to the present, I go and I find the image that was taken at that time, and I draw it in a window, and then I overlay on top of it the position of the sun, the moon, and the stars that were calculated using their respective formulas that happen to work on a spherical Earth. I can choose to draw the stars or not draw the stars, and I can choose to overlay the image that came from the camera or to not overlay the image that came from the camera. But in all that time, with the exception of me bumping the camera or taking the camera down to repair it, I did have quite a few issues with this camera on a number of occasions. The camera's placement was not always exactly where it was before, and you can see that the position of the house shifts slightly, and when that happens, that the alignment between the computed star position and where the camera saw them in the image are not the same anymore, and I couldn't be bothered to go through every time the camera bumped positions and readjust the settings for the generated star field. But you will see that Polaris is always right around here, and Kochab, which is the second star that is almost always visible, rotates around Polaris like this, and that regardless of the time of day, regardless of the year, with the exception of the camera being bumped, the computed position of those two always remain pretty close to reality. The reason why it's not always perfectly tracking is because I'm not accounting for the barrel distortion of the camera. But there is another thing that I would like flat earthers to explain. Why is it that the stars rotate counterclockwise around the northern celestial pole like you see here in a 24-hour period, but that it also rotates for the same time of day throughout the year? If I look at the south-facing camera, the same is true. If I orient my camera with a zenith angle of my latitude and point due south, everything in the northern hemisphere appears to be moving left to right like you see here in a 24-hour period, but it also rotates left to right like this for the same time of day throughout the year. I'm going to include a time lapse of the first image that was taken from the north-facing camera after midnight, every night that the camera was in operation from the start to present, and pay close attention to where the computer calculated the position of the stars, particularly Polaris and Kochab. Because I had to keep fiddling with the camera, its position shifted slightly, which explains why the computed position of the stars don't line up with the position from the camera. That's going to be it for the moment. Thank you for watching, and I'm going to see you in another video at some point soon enough. Bye for now.